So thank you very much for joining us today. I'm going to spend maybe about the next 35 or so minutes, hopefully giving you a few tips talking about design tables. But before I do that, I do want to give credit where it's due. Nate Marsh put this presentation together a few years ago. Let me share it, or he shared it with me. Let me add my own little spin, my own little take to it. So with all of that said and done, let's go ahead and jump into things here real quick. So I'm going to primarily discuss part level design tables today, but I want to also add that what I'm going through is very much applicable to assembly level design tables. So you'll see examples focusing around the parts, but it is pretty general here. So I'll start with the basics, a little bit of review, just touch on the backgrounds of part level configurations. We'll go through a few examples talking about the basics of the design table, or that that Excel spreadsheet to help us build our Solidworks configurations. Talk about a few things to help us plan a design table. I think of design tables as kind of dipping our toe into automation. And in order to have a nice situation, we need to have a few things taken care of. So we definitely want to have a plan when we get into this. Some tips on executing. It's all about, again, trying to make sure that we've dotted our I's, crossed our T's, and we've tried to think of everything that we need to. And once we get through these little preliminary examples, we'll look at a real world example. It's a simple example, pipe, but because of the variation in a model of pipe with the wall thicknesses, the diameters, and the lengths, add in different material properties, you'll see that what appears to be very, very simple could then quickly generate just dozens upon dozens or hundreds of configurations or variations here very quickly. And then we'll look at an application of design tables and configurations using the configuration publisher. It's a user interface that allows us to basically set up what the end user will see when they want to add a part to an assembly, for example. So don't see those used too much, so I wanted to add that in here just to share a little bit more information. So as we talk about configurations, I think of it really core SOLIDWORKS functionality. It's all about that different versions or variations of our model stored within that single part file. And that's an important piece of information. One part, different geometrical versions. You know, most commonly we'll use dimensional changes in our configuration. So the part's a little bit larger, a little bit smaller, larger diameter, smaller diameter, things like that. We can suppress features, turn them off, suppress, unsuppress, or turn them back on. But we can also configure materials. We can configure custom properties where all of this information is unique per configuration. Now, this is by no means an extensive list. I'll show a picture of the help file here in a little bit where there's dozens of parameters that we can control in our configurations and ultimately in our Excel-based design tables. So we'll jump into SOLIDWORKS here real quick. And as I mentioned, I am using a very, very simple part. My little tube, my pipe with a hole in it. So 2 features, a boss, and a cut. Simple example, but it does convey the ideas and a few things to think about when working with design tables. So here we have our configurations as I cycle through them in the configuration manager. Simply toggling that feature on or off, or suppress and unsuppress. So we have the hole, we don't have the hole, in a couple of different sizes. So nothing groundbreaking with that model, that's for sure. And what we're going to do is we're going to use that very simple example to help us build a family of similar parts and ultimately similar assemblies. The good old hex bolt there, perfect example of a SOLIDWORKS part, or really any part that's configurable or that we would want to apply a design table to. Similar shapes, simply different diameters, different lengths, different sizes on the hex head itself. I like to say you would never use configurations to turn a model of an end wrench into a hammer. You know, those are a little bit two different geometries there, but maybe a family of end wrenches would be a good example for configurations, or any scenario where the models are, air quotes here, mostly the same, but ever so slightly different here or there. Now, what we'll look at today is kind of this family idea using design tables. But of course, you can use configurations and design tables in a lot of different ways. Maybe you want to simplify a part, Configurations are great for that. Set a part up for finite element analysis and remove geometries that aren't critical to the analysis. Also another good example of configurations in design tables. So the basic format of the design table, just to touch on that, it is an Excel spreadsheet that lives inside the Solidworks file. That's a very important piece of information there. And it basically builds configurations for us. In its most simple case, Excel helps us make configurations. Configurations change our parts in this example. Now, when we look at a table, we have to place the information in very specific locations. So all of our named configurations are in column A, that left-hand side, excuse me. Every parameter that we would like to control is across the top. You can see PRP at part number, that's the part number. Length at pipe is a dimension. $ state at hole is for feature suppression. So everything goes by default in that row 2. Now to put it all together is cell A2. Notice it's blank, and that's a very important cell. It's called the family cell. Technically, the family cell can be anywhere in the design table, but I'll use A2 as the default example here. All the cells below A2, those are configuration names. All the cells to the right of A2 are all the parameters that we need to control. So that's simply how the software interprets the Excel-based information. Be very, very careful with your syntax. Any misspelling for a parameter will cause it not to work. Any extra spaces will cause problems. Any skipped rows or columns will cause problems. Of course, if you misspell something in your configuration name, well, everybody's going to see that. So be very, very careful with the syntax. It's really, really important when setting up a successful design table. But when it's all said and done, creating one of these is super easy. Insert tables, design table. It could be blank, which I don't think anybody hardly ever does. I've never done it. I don't think I've seen anyone do it, because that is an empty spreadsheet where we have to fill everything in, and it can be a little bit cumbersome. Another option is to link it or link it from an external file, fairly common. But again, we need to have that spreadsheet built with all those parameters in the correct locations. So when we bring it into SolidWorks, the software understands what's going on there. Now I've left the most common, and that is auto-create for the last, because I do want to spend the most time talking about it. This is what we all tend to use, at least in my experience. It's what I use when I create a design table. And this is SolidWorks kind of guiding us through the process. So there's 2 different ways that we can auto-create a table. And if we don't have any configurations in our part, or just the default, we'll get an intermediate window to select the dimension or multi-select the dimension using either the control key or the shift key. And SolidWorks will then populate our design table with all that selected information. Now, that's not the only way that we can do it, but that's what we'll see the first time we insert that design table. If your model already contains configurations, everything that's unique from configuration 1 to 2 to 3 to 4 is brought into the table automatically. So there you can see in column A, the names. SolidWorks also will add in the description for us, the part number, the color representation, and then dimensions that are unique, the $ state to suppress. Again, that's unique, but it won't add all features and all dimensions, only what's different. So let's look at this. So we'll use that super complex pipe model again, or rod with hole as I've named it. The 3 configurations, we've got 2 3-inch configurations, 2 6-inch configurations, each with and without the hole. And we'll go to that insert pull down menu here, and we'll insert the design table. So there we have insert tables, design table. And I'm going to use all the defaults. So leverage auto create for this first example. Once we say OK, Excel is loaded up, and we have full Excel functionality at this point. So it's easy to make it larger so we can all see it. We can use some Excel formatting to make the cells auto fit. But there we see the same configuration names in the design table as we had in the part model. But we've got, again, that description information, $ description, $ part number. Here we have that length at pipe. That's a simple dimension, evaluated at 3 and 6 respectively. And that final column, column F, $ state at hole, we can see feature suppression there. So SOLIDWORks automatically formats the table and puts this information for us, that little drop down. It is pretty easy to simply type in an S for suppressed to shut that feature off, or a U for unsuppressed to turn it back on. But if you like to use the drop-down tables, they're kind of neat. SOLIDWORks puts them in there for us, and they're pretty easy to work with. You can type all the text in. You can use ones and zeros, as you can see there on screen. So you do have quite a bit of flexibility. When you're done editing, click into SOLIDWORks, which we tend to do accidentally, at least I do. And now all of our configuration icons have little Excel symbols next to them. So now the design table is driving everything in this particular part. So very easy to add them in there. Typically, we'll need to add more information to our design table. So once it's once it's inserted, how do we edit? Like everything in SOLIDWORks, we just right click. So right click, edit table, that'll get us into modifying the spreadsheet inside the SOLIDWORks UI, just like you saw a moment ago. Understand that we have no SOLIDWORks functionality at this point. Our ribbon, our command manager, our pull down menus, everything is replaced with Microsoft Excel. Now, if that's not how you prefer to use the environment, you can edit in a new window. And this is great for multiple monitors. Doesn't work that well for a presentation. But then you'll have SOLIDWORks on one screen, Excel on a separate screen, and you can work side by side. One thing to mention about editing in that separate window is the Excel spreadsheet still exists inside the SOLIDWORks model. It's just being opened up in a separate Excel instance. And you really don't need to save the spreadsheet, just X out of it, close out of it. The file will get auto-saved and essentially reabsorbed back into the SOLIDWORks part. Now, to add additional information, things like features or dimensions, anything that we need to, it's all about selecting the appropriate cell. So that next cell in row 2 and double click. Double click to add a dimension if you can see it. Double click in the tree to add that feature to control feature suppression state. And simply type in a new row and start filling in the data to generate new configurations. So let's walk through this very quickly. Now, there's a few things that I want to mention when editing a design table and adding extra information to it. So as we just update all the configurations here, we'll right-click and edit that table. And we'll see it jump up right inside of SOLIDWORks. And the first thing I'm going to do is intentionally activate a non-row 2 cell. So in this case, I'm going to focus on cell E8. The reason I'm doing this is when I go to the feature manager tree and I double click on a feature, I don't want it to be automatically added in because I don't want to control the suppression state of that feature. I'm using double click to simply show the dimensions. So I'm selecting a non-row 2 cell. That's a mouthful. We'll jump into the feature manager tree, double click on the feature so I can simply show the dimensions. And now I'm intentionally selecting cell G2. So that's the next open cell in that row 2 there. Now we'll go into SOLIDWORks, double click on the dimension itself, and the code or the full name for that dimension, pipe diameter at pipe sketch, is added to the design table. So very deliberate actions. So I only get the dimension that I want and I don't accidentally get that $ state at pipe to suppress it. So once you're done, click into SOLIDWORks, makes the change, and we can cycle through them. So it is fairly easy to do as long as you're careful, at least in my experience. Just be slow, be deliberate. Something I'll talk about here in just a moment. I want to point out the color of those dimensions. Notice they are pink. That's a long old setting inside of SOLIDWORks that any dimension that's controlled via a design table gets that bright pink color. Of course, you can change it. But this message just lets me know that I accidentally am trying to change it, and that dimension is controlled in the design table, and it will be updated in the design table if I make that change. So we'll talk about what that happens or what that means here in this example. So those options that you can see when you're editing the design table feature, not editing the table itself. Here we can see it's the edit controller, what I like to refer to as a bidirectional design table versus a unidirectional design table. So I created my table with the allow model edits to update the design table. So any dimension I change, I'll get the message and it populates that appropriate cell in the design table. I do say if you're going to use this kind of bidirectional behavior, that warning, while it may be a little bit annoying, it is important so you don't accidentally change a dimension without understanding the possible repercussions of updating that design table parameter. So there you can see warn when updating the design table. So either we allow it or we block it, one or the other. Thankfully, you can change it as many times as you need to. So back over into SolidWorks, we'll open that part up. I guess it was silly for me to close it there. And as I open it up, we'll look at everything that we've got set up with the design table. So right-click, edit the feature, and there, allow model edits is on, just like I created it initially, and warn when updating the table is on. So kind of the default conditions. So now when we decide to edit the design table information with a right-click edit table, we'll change one dimension here, the 6-inch width hole, from 1.25 inches to, let's say, 1.5 inches. Click into SolidWorks, everything rebuilds. There you can see subtle, but the OD changes. So there's the old value and the new value. Double-click the part, double-click the dimension. We get that message. It will pop up every time. And I recommend do not select the do not show this message again. Just keep this up. Get used to saying OK to it because it will pop up several times. You select the dimension, double-click there, it pops up again. Yes, I do need to say OK another time. And now I can type the value in. So it just keeps you honest, if you will. So we'll switch that back to 1.25 inches, accept that value, rebuild the part, and we'll jump back into the design table. So very simple example, but once we edit the table, notice the dimension is still 1.5 and then it flips over. So it just takes a second to update the information in the table from the dimensional change. Now, if we change it over and block those edits, well, we simply can't change those dimensions. Once we do that, we'll get a message telling us that that dimension is locked or associated to a field that is locked. There you can see it there. If you really needed to change it, of course, you could flip that switch, turn on the allow model edits, and make your dimensional changes. So there's no limitation there. It's just something that you need to be aware of. Lock it and unlock it, or I should say allow and block those changes. So we've gone through some very kind of basic scenarios of setting the design table up, inserting it, editing it, things like that. But what about the part model itself? They really do have to work hand in hand. I like to say create a configuration-friendly model. That requires robust design intent. As I mentioned at the beginning, to really simplify everything, the design table, it doesn't do anything more than build configurations, and configurations really don't do anything more than, in our case, change dimensional values and suppress and unsuppress features. So it really just changes the part model. That part model needs to handle those changes. The design intent, or our plan for change, or our plan for how it should behave when it changes, it needs to be solid. We don't want to have rebuild errors or holes that fail or features that try to rebuild off the part or anything like that. So the part needs to be very robust. Typically, it'll have more features, and that might be a bit counterintuitive. But if we look at this example, just a revolved hub or revolved geometry to create a hub, I've built everything in a single sketch. Super common, very, very efficient, but not overly flexible for configurations. Now, of course, every dimension can be configured and all that information can go into our design tables. But if we break that part down into individual features where there's a revolve and then a cut revolve and another cut revolve and a cut extrude, et cetera, every single feature in the tree can then be suppressed and unsuppressed. So we have more variations, more flexibility in the part model. I say avoid child features, which we all know it's impossible to do in SolidWorks. So I should say just watch the child features. And what I mean by that is when you suppress a parent, those child features will be suppressed as well. Think of maybe a cut pocket with fillets in the corners. Suppress the cut, well, those fillets will be suppressed as well. So you don't want that to happen accidentally is what I'm getting at here. Just be aware of those parent-child relationships in your part. Make sure that everything is working as expected and you don't accidentally suppress some undesirable features. So when your part is solid, what about the project itself? You know, how many configurations do you have? How many features do you have? As I mentioned, probably quite a bit. If you're going to break it down into more features, well, that's going to add to your project complexity. So there is a kind of a happy medium of too many features or maybe just enough features so you can configure everything appropriately. How many configurations? 1, 2, 3. Maybe just use standard configurations, 20, 30, 40. Definitely think about design tables. Is the model complete? I see this quite a bit. You start some form of a project and you immediately throw it into a design table, and then you realize, wow, I need these extra features and these sketches and so on and so forth. Is everything set up to work correctly with your design table and everything linked up that way? So just something to think about. Does the model have external references? So is the part, designed top down within the assembly? I will say be very cautious on this. Top-down models, external references, those are really more intended for those one-off models where something that is going to be in a design table, that's a family of common parts. We'll probably use them over and over and over and over. They tend not to work that well together. Not saying you can't do it, just be very, very cautious of that. And what about equations? That can definitely add to the project complexity. That can help with the automation. Maybe less parameters in the design table that you're controlling, more automatic updating within the SolidWorks part model. Again, it can all work together. And of course, those equations can be Excel formulas and Excel equations. Very powerful tool. You can really do some programmatic functionality in your Excel file to really help drive the part. So another thing that is a good recommendation is naming features in your tree. I like to say keep it clean. Rename your dimensions. So instead of the dimension being named D1 at sketch 1, I've renamed it, as you can see, pipe diameter at rod sketch. And I'm not saying rename every single dimension, just the dimensions that you're going to change and work with. Same is true with your features. Makes much more sense possibly to have the feature boss extrude named rod or whatever the case is. I know I've done it, deleted a feature that I thought was insignificant, but it was very, very important. Get the tree blown up. Thankfully, I could undo back to safety. But if you just rename a couple of features, they're easy to locate in the tree. You can use the tree filters to find things effortlessly, but also make sure that you don't accidentally remove one of those features. That's extremely critical. Now, for renaming, it's that left click, pause, left click, or you can select and use the F2 key on your keyboard, kind of the universal Windows hotkey to rename, works just as well. So I mentioned earlier, we're talking about planning for the design tables and the parameters you can control. I've controlled dimensions and feature suppression in this example, but that is not the be-all, end-all. You can see on screen, I understand it's probably very hard to see. So I highly recommend that you look in the SolidWorks help and search for summary of design table parameters. You can modify and configure everything from sketch information to dimension tolerances to colors and a ton in between. So take a look at that, and you can use all this information to really build a very, very powerful design table. So a few general tips. This is just really basic here, but start simple. It may seem like a no-brainer, but I can't tell you how many times I've worked with customers that have gone so far into a design table that nobody else can edit the table, nobody can work with it, you can't share the data with anybody. So just start simple, make sure everything works, and then expand from there. Testing is critical. We're talking about kind of baby steps into automation. The model must rebuild correctly. The design table needs to be robust, because the whole idea is to make it very, very easy to build a large family of parts. I don't want to generate a family of flawed parts for the design team or for everybody to use. So make sure you test it. You cannot skip rows and columns. If you do, SolidWorks completely ignores anything below a skipped cell or to the right of a skipped cell, but that doesn't mean you can't add information as notes because you can put in user notes. So $user_notes. So I'm kind of highlighting some of the most common or maybe needed parameters here. So if you do need to skip a cell, there you can see 2 rows, $user notes. These have configs, or these configs have holes versus no holes. Notice there's no spaces. It must be user_notes. So that's kind of rolls back to one of my initial slides. Syntax is very, very important. And then finally, save a copy of the design table. Because that Excel spreadsheet exists inside the SolidWorks part or inside the SolidWorks assembly, you don't want anything bad to happen to it. So right-click, Save Table, and you can extract it. Now, it is not a linked table at this point. In order to do that, I would need to add in a design table and choose that Browse option. Now, the kicker is you can only have one design table per part model. So you would need to save the table, delete the table, and then add the design table back in with that linked to table option on. So it's kind of a complex workflow, but it can be done. But this is more for save that backup copy for just in case. So now we're going to look at a real world example from all those little tidbits of information I've gone over here. So pipe, as I mentioned, super simple to think about, but from a configuration and design table standpoint, actually quite complex. So just looking up here, you can see carbon steel pipe schedules just out of some documentation. 106 possible sizes and schedules with 4 different materials. There you can see over 400 combinations. But what gets really tricky is the number of lengths. So each of these sizes can vary 1 inch to 20 feet in 1/8 inch increments. When you work all the math out, all possible combinations of over 810,000. I would never recommend that you create a design table with 810,000 configurations in there. That would be a bit cumbersome. And in all honesty, this isn't 100% realistic because you would never have a pipe that's, 24 inches in diameter that's 1 inch long. So yes, there are some configurations that don't make sense, but you can see how quickly something that seems very simple could be hundreds and hundreds of possible configurations and why using a design table is beneficial for that. Now, in our example, we will also look at a pipe, but I am not going to make you sit here while I make 810,000 configurations. I'll build, I think, 20 of them. So to help facilitate this in the Excel spreadsheet, leverage some formulas to auto increment that 1/8 inch value. Some drop-down boxes help us make sure that we have the appropriate schedules and we can link everything together. But what's really helpful is the concatenate formula. One of the most time-consuming aspects of building a design table, in my experience, is creating every single configuration name. And even if it's quick and you can copy and paste it, they all must be unique. So you need to change parameters here and there. And it's also quite error-prone. So leveraging concatenations can really speed up creating all those configuration names. Of course, what other Excel tools, other formulas, conditional formatting? I mean, you have the power of Excel at your fingertips, so you could really use anything that helps you out. So here's the Excel spreadsheet. This is a separate file that we'll read in. And as we take a look at this, you can see, I'll highlight the length field here. That's the first keyed in value, 1 inch, and then a formula. So E3 plus 0.125. And because it's Excel, you can copy and paste all that, and it auto increments the cell and just continues to take the next cell plus 1/8 of an inch. So really, really easy to generate all the lengths in this example. The schedules, they all need to be the same, so all those values can be linked up. Here we have a drop-down list we've created. Switch them all to schedule 40. They all change, and to the right, that's the data that the drop-down list is picking up. But what's really neat, as I mentioned earlier, that concatenate formula. So we've got some text of pipe and schedule, and then linking to various cells. Because we've got the schedule linked, we change the schedule, it changes everything automatically in our name. And again, we can just copy and paste that information and change the one cell in the length field that's unique. So this one is linked to 2.5 inches versus 1 inch. So it really speeds the process up. It's not overly difficult. It can just be time consuming to generate dozens and dozens and dozens of configurations. And I guess I made a mistake. I'm only building a total of 17 configurations, not 20 here. But now as we jump into SolidWorks, we'll open up our little pipe model. Same thing, an extrusion with a bevel and some sketch information. I just pulled this out of the routing library. One default configuration. We'll go to Tables, Design Table. We'll choose From File and Browse, and we'll load that Excel spreadsheet up. Once we say OK, everything gets brought into Excel. Might take a moment or two to load a lot of Excel-based data into the file, generates the configurations, and we'll say OK. And then we can just simply double-click our way down the configuration manager on the left, and we can see the lengths increase. So it doesn't take long to go from a single part, a little bit of time building our design table, using some of those nice Excel tools, and now we've got 17 different pipe configuration lengths to work with. And you can just keep expanding it and continuing that process. But since we're limited on time, I'm going to jump into some other aspects that we can leverage and use configurations and design tables for, and that is the configuration publisher. So this allows us to control, or I should say build and control a user interface so another user has an easier time selecting configurations to use in assemblies, for example. Very much like the Toolbox UI that I have a screenshot there, but we're going to go ahead and build one of these from scratch just so we can kind of see how it works. It's been in SolidWorks forever. Don't see it used that frequently. I think a lot of users just forget that we have access to something like this. So the first one we're going to take a look at is a single line table. So notice there's one configuration default and the different parameters that we want to control. If this is the direction we take, the design table is basically the engine to build configurations dynamically. Again, we're using some of the Excel functionality to link everything up. Once we load the design table, we then add the configuration manager, we right-click on the configuration manager and add a configuration publisher to the model. So here's that design table I had a screenshot of just a moment ago. We'll go ahead and show off that default name. There's the concatenate field. But that's all the information that this design table is going to have, no extra configuration lines. As we load the pipe model up, we'll then insert the design table to that particular model. So back to that Insert Tables Design Table, and we'll go From File and Browse. Want to make sure that this one is linked so we could make changes externally if we need to. And we'll go ahead, let that load in here momentarily. And that's all we're going to do as far as generating the table, editing the table, and working with it. The next part of this process is to right-click at the very top level and choose the configuration publisher. Notice it loads up the table, and there we can see everything in the background. So once we get this table up, we can then just drag and drop our fields, start filling them in to control what we want the end user to work with. So we'll add in a few cells here. So super simple, drag and drop, name it whatever it is that we need to name it. And this is going to be something the end user interacts with. So we'll make it simple. We'll call it nominal diameter, link it to the design table variable, and we'll set up a drop-down list and just key in the values. So this is something that the end user will pick up. And we could continue to do this however many lengths or values we need to, but now we'll skip ahead here and we'll just drop in a second list. So this is going to be the actual outer diameter, and we'll link that up. And what we'll do is we'll set a little bit of a data dependency, or we're going to make the nominal diameter a parent of what we're doing here. So this is going to be something that basically happens behind the scenes. When the end user selects the 1/4 inch value, the software is going to plug in 0.540 to the outer diameter at pipe sketch. So this is going to happen behind the scenes to help us build those different sizes. That's what's important to understand here, is we're not choosing configurations We're building configurations because it's a single line table. The schedule, well, we'll link that over to the schedule property. We could set that up with a dependency as well. And for each size, each value, we'll just set this first example up to be schedule 40, but we could have our line items, schedule 20, 40, et cetera, whatever it is that we need. So it's just a matter of repeating this process to get the table completed. Now, through the magic of presentations, we can jump through a little bit and see that I've added in wall thickness, weight per foot, material, so on and so forth. So it's just a matter of kind of repeating this process. So now we'll get back into SolidWorks and we'll look at using all of this together, and we'll open up a completed model that has all that property or configuration publisher data within it already. We'll edit the feature of the property manager. That's what it gets called. It'll load up the design table. Don't be surprised if there's a little refresh issue. And then we can go to the SolidWorks Preview tab and see how it works. So this is that testing process that I mentioned earlier. The one entry or the one area where we're letting the end user key in a value is the length. So we could specify, different diameters, different schedules, different lengths. But notice there's only one configuration in the property manager. To test it further, we could add it to a sample assembly. Not sure what that's all about, so I'll just say OK. And we'll say green checkbox, and on the left is our defined property manager. So this is what it looks like to the end user. Specify the diameter, the schedule, key in a value, say OK. Now SolidWorks is actually building that configuration. So the design table loads up, goes through the calculations, it'll disappear, rebuild the part, new configuration defined. Configure part assembly button. We could redefine everything, go back in and make some changes. So let's go ahead and do that here. And let's change a different size, maybe 3/4, different schedule size, different length. I think you're starting to get the picture here. It's just a matter of using that design table as the engine to help put everything together. And there's the little bit longer one. Now, when we switch back over to the part and notice the property manager now, or the configuration manager, we have 2, 3 total configurations now. So eventually, they do get added to the file, but initially, it's just an engine. So the other method is to use the configuration publisher with a complete design table. So everything is done. All the configurations, all the parameters, all the different sizes. It's essentially a nice interface to switch configurations in this case. And I'm not going to go through the example of building it. Let's just take a look at using it in action. So this is a different part, a little link with a couple of holes. Notice the configuration manager, all the configurations listed. If we edit the table, again, everything is already done. So we've already done the work. We've figured out all the different sizes the end user could ever need, and we specify it all in there. So that's kind of the 2 different ways of using this functionality. Now, as we jump back into SolidWorks, we can go over to the configuration manager, edit the feature, loads that table up. Like I mentioned, it does take a second to load everything in there. We're working with a bit of data. There you can see some of that refresh issue I was mentioning. But once we update the model, it usually goes away. Sure enough, it does here. But we can just cycle through and test everything, make sure that it's working exactly as we expect. But on the left, it's really just changing the configurations. It's not building anything. We don't have to wait for the software to update it. So now the final test, let's add this to a test assembly. We'll green checkbox OK. We've got the same type of user interface, but there's no data entry in this example. We're just grabbing information from drop-down lists, different lengths, with and without the hole on the right, different thicknesses, or what I've called the width, or I should rephrase that. The depth is actually the thickness here. But we can get to and redefine that configuration the same way. There's that depth value. So it works similarly. It's a little bit faster because we're not waiting for the software to build it. And from the configuration drop-down list, we can see all those configurations exist, and we could get them that way. So a couple different ways to do that. So that about wraps it up here. Just to touch on where we've been, focus primarily on part level design tables and the different things we could do with them. brief review of our configurations, talking about some of the basics and the formatting and the lay of the land and where information must go within a design table. A few topics and tips thinking about planning. You don't want to jump into one of these without at least having a basic plan. Some tips on executing. Again, that was starting small, testing, saving that table out, very important there. And then we looked at that pipe example to build over 810,000 possible configurations. In our example, we built 17, so a little bit more realistic. And then right at the end there, introducing the configuration publisher, looking at some other functionality that really leverages the capabilities of design tables. So with that, I will wrap up by saying thank you, everyone, for your attendance. Thank you very much. I appreciate it.